In this video, we're going to go over problems 32 and 33 of the review assignment, which is where we're looking at the shapes of curves and looking at what we know about the slopes and the concavity and other questions that might be given to us. So in this very first graph, it's really important for us to know what we're looking at. And in this case, we're simply looking at the function itself. And so our very first question asks us, on what intervals is f positive? We're looking at f, so it is positive anytime it is above the x-axis. And so we can see from x2 to x5 to x6, all that time it is positive. And so we can simply write from x2 to x6. The next question asks, when is f prime positive? Well, f prime is positive when f is increasing. And so we can see from x0 to x1 we're decreasing, but from x1 all the way to x4 we are increasing. So from x1 to x4. And then we decrease to x5, but then we're increasing again all the way from x5 to x6. The next question asks us, when is f double prime positive? And we know f double prime is positive when f is concave up. And f is concave up from x0 to x3. This is actually the inflection point. So x0 to x3. And we'll notice that it is concave down from x3 to x5 and also from x5 to x6. We're next asked for critical numbers for f. Recall that critical numbers are when f prime equals 0 or f is undefined. And our slope is 0 right here at x1, at x4, and it's undefined at x5. And that is because our tangent line is 0, our tangent line is 0, or over here our tangent is undefined because it's a sharp corner. So our answer in this one is going to be at x1, x4, and x5. And we've already answered this one. Where is f prime undefined? It's undefined at x5. Next, we're asked, when is f prime decreasing? Well, f prime is decreasing when f double prime is negative. And f double prime is negative when f is concave down. And we are concave down starting at x3 to x5, and again from x5 to x6. And we can see that in the shape. So if we were to draw this right here, as we go along here, we're concave down, and then along here, we're also concave down. All right, let's clean the graph up, and let's go to our last question, which asks us, when is f prime the greatest? And when we're asked for f prime the greatest, we're basically asking for the steepest positive slope. Steepest positive slope. And so we want positive slopes, and the steepest actually occurs right here at that point of inflection. And why is that the case? It is the case because when f prime is the greatest, is the maximum of f double prime. Is f double prime, equals 0. Because we're looking for the f prime's max, we take the derivative of f prime, which is f double prime. We're looking when f double prime equals 0. That's an inflection point on f. So f inflection point. Okay. But you can also just look at the graph and take a look at your slopes. You can see you're going 0, steeper, steeper, steeper. Here's that steepest, and then we go less steep. All right, moving on to question number 33. This time we're looking at g prime, not at g itself. And so we have to keep that in mind as we answer all the questions. So when it asks how many critical numbers g has, recall that we're going to look to see where does g prime equal 0. We're looking at g prime, so g prime equals 0 at all of these x-intercepts at x1, x3, and again at x6. Our next question asks, when is the instantaneous rate of change of g positive? That's just a really long way of asking us, when is g prime positive? Okay, so we're looking at g prime, so it is positive. And if we let's take a little time to draw in here, it is positive anytime I am up above the x-axis because I'm looking at g prime. So my answer is going to be, go back to a pen, is from x0 to x1, from x3 to x6. At x6 we're not positive because we actually equal 0, so we break it up there, and then again from x6 to x7. All right, our next question asks on what interval is g decreasing? All right, so g is decreasing when g prime is negative. All right, well, g prime is negative, this one bit that dips below. It's the opposite of the previous question. So from x1 to x3. All right, so then let's move on to the next question, which asks us on what interval is g prime decreasing? So recall that when we're asked about when g prime is decreasing, that's the same thing as saying that g double prime is negative. Well, actually, you know what, we don't really need to do that here, though it's true. We're looking at g prime. G prime is decreasing when it's going down. So that's from x0 to x2. Let's see, switch colors. So x0 to x2, we are decreasing. We're going down here. And then we're going up all the way to x4, but we're decreasing again from x4 to x6. Now from x6 to x7, we're increasing again. All right, let's look at our next question, which asks us, when is g double prime positive? Well, g double prime is positive when g prime is increasing, which is the opposite of the last one. So g prime is increasing from x2 to x4, and g prime is also increasing from x6 to x7. All right, next we're asked, when does G have a local maximum? We know those local maximums are going to happen at some of these critical numbers, so let's consider those. At x1, G prime goes from positive to negative. That means it was increasing, then decreasing, which means I have a local max. So that's going to be what happened at x1. Then at the next one, at x3, G prime went from negative to positive. That means I was decreasing, then increasing. I have a local min, which means it goes through here. And our last critical number, we went from positive to positive, which means it is not a local min or a local max. All right, our last question asks, when does G have inflection points? Now recall, inflection points happen when G double prime equals 0. Actually, let me back up. It's not when G double prime equals 0. It's when G double prime changes sign. Okay, so let's talk about when does G double prime change sign. So G double prime is the slope of G prime, right? So that means when the slope changes, that's when I have an inflection point. Okay, so G double prime is the slope of G prime. I'm looking at G prime, and when the slope changes sign, then I'm going to have an inflection point on G. So let's just draw on this again to see what's going on, and we'll get some of our old markings out of here. So here we go. Right in this first section, G double prime is decreasing, which means the slope of G double prime is negative. Then the slope of G double prime is positive, and then the slope of G double prime is, or sorry, the slope of G prime is negative, and then the slope of G prime is positive. And so our points of inflection are actually at these values where they change, at x2, at x4, and over here at x6. Now, you should note that these are the local extrema of G prime, and that is an important thing to remember, that local extrema on G prime are inflection points on G. All right, that's it.